So I'm drawing this triangle. I'm going to put the one angle in the lower left position. I'll draw it roughly to scale. Most of the time we don't draw them to scale, but the angle I've been given, in this case it had to be, I don't know why today they're all A. I need to change up my presentation so they're not all angle A. I've been given side length B. Well, I'm going to, the next side, in fact, this would be side A over here. The next side I'm going to label, I'm going to put on this side here. Always keep the first side you can label on the left. It really helps. B equals 12. So this would be vertex B. So this would be vertex C because it's triangle ABC. So this is side length C, and that is 16. To find the area, look at what we've been given. We have been given a side, an angle, and a side. That's the known information. So I can just use the formula 1/2 of side 1 times side 2 times the sine of the angle in between. So it's going to be 1/2 of 16 times 12. And it wouldn't matter if those were written the other way around. You're multiplying, doesn't make any difference. Times the sine of the angle that's in between them. Doesn't matter that it's obtuse. 110 degrees. Stick that in a calculator and out comes the answer. I've prepared one earlier, it's down here. The area you should get out is 90.210. That's the 3 decimal places. And were those in, oh, say those were in centimeters. This would then be in centimeters squared. Science teachers would go nuts with us for not putting units on. I've made up the units there. Okay. So we could practice some more of those, but we're not going to. I know what today's lesson is like. You've got some more to practice in your homework, but just look out for, have you got side, angle, side? Your area is simply going to be 1/2 of one of the sides times one of the other side, the other side, and the sine of the angle that sits between them. You just stick that in your calculator and out pops an answer. While we're on this though, I am going to talk about height. The height of this triangle would actually be there. If I link this up, I could make a second triangle that's got this same angle, and this side here is the same, and this would be the hypotenuse of a right triangle where this side here was the height. The sine of 25.89 would equal what's opposite it is this height, divided by the hypotenuse, which is opposite the 90, 52. So your height would be 52. Multiply both sides by 52. And that's what you'd get for your height. Okay. We're not going to do the second example at all because I want to get on with the lesson today. Right. Do you remember geometry? Do you remember proofs in geometry? I bet it was your favorite maths you did at any point in time. Okay. Now, when you were proving congruency in geometry I think it's when you first learnt these, write down this list. AAA stands for angle, 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 side, side, side. Angle, angle, side, angle, side, angle, side, angle, side, 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 angle. Okay. Now, when you're given information, if that given information, you've been given 3 pieces of information about a triangle, and there are 3 angles and 3 sides. So there's 6 pieces of information that exist about that triangle. If those 3 pieces of information can only give you one solution for the triangle, then you've proved congruency. That's what you were doing when you were working in geometry. Now, we're not doing proofs, don't worry about that. But it's just the fact of how many solutions could you get given this information. Angle, angle, angle is the one that's really, really weird. Say, let's take a really simple triangle, an equilateral triangle, 60, 60, 60. I could draw one like that. This one has the same angles. Are they congruent? Are they exactly the same? No, not at all. There's an infinite number of solutions. if you're given angle, angle, angle. That has an infinite number of solutions. So it could not be used as a point of congruency. If you're given all three sides, there's only one solution possible, so that was a proof of congruency. Okay? Looking at this list, does anybody else know which is, there's one more on that list that was not a proof of congruency? Anyone know it? I will give you a clue. Teachers are very careful because we're very straight-laced. We're very nice people and we never say bad words in class. And so we always write the letters in one particular order. If we wrote them back to front, it would say a rude word. Yes, Paula. Yes, Amara, you got it right. It's this one. These are all fine. They all worked as proofs of congruency because they all had one solution. This one wouldn't work because when you're given side-side angle, there could be no solution. You might have one solution, which would be a right triangle in this case. Or you could get two totally different triangles. Okay, so you might have been told that there was no donkeys in geometry. Well, unfortunately, we have to deal with the donkeys. Okay, and some of them are cute and some of them are obtuse. Let's have a look at this one. So remember what I said, if you've been given an angle, we've only been given one angle, put it on the left. Now, obviously this is an obtuse angle, so my picture I've just drawn there is not great. That's, it's not important really. To draw it to scale, I'm going to just draw that roughly to scale. Okay, so whatever angle that was, put this letter in the lower left. The side opposite would be A, and we've been given that. A is 5. If you've been given another side length, don't put it at the base there. Always next, choose to put it here. That helps you calculate the height. It helps with all sorts of things, okay? So the other letter we've been given there is B, and B equals 6. I don't like that with that dot there. It's going to annoy me forever. So if that was side length B, side B, across from it, this must be vertex B, so this must be vertex C, so this must be side length C. It's hard to tell with the C's which is an angle and which is a side length, just from the size of the letters. So find all the solutions for the given triangles. That means solve it, that means find all the missing lengths and all the missing angles. So we have to work out the size of this angle, the size of this angle, and the size of that length of this side. It's not a right triangle, so we can't use Pythagoras and we can't use SOHCAHTOA. But look what we've got. We have got an angle and its corresponding side. We've got things that are opposite like that. That means we can use the law of sines, which we did yesterday. And the law of sine says, make a ratio. Get the sine of your angle, so it's the sine of 135, and divide it by the length of the corresponding side, the side that's opposite it. Okay, now we're going to have to choose a letter. Could we do the C's next? We don't know angle C, and we don't know side length C. No. You can't solve if there's two things you don't know, so we can't do that. We're going to have to do the B's. We don't know angle B, so we're taking the sine of the angle we don't know, but we do know that the side length B is 6. Okay. So let's solve that now. Cross multiply. When you're cross multiplying, this is the part we want is here. Get rid of this by multiplying it up there. That's what we're going to do. Don't draw this stuff all over your notes. You just can't see what I'm pointing at today, so I'm going to keep on doing that sort of stuff. So this would give us sine B equals 6 times the sine of 135 degrees divided by 5. Plug that in your calculator. Please practice using a calculator. It's really surprising how many people can't get the right answers out of their calculators, and you don't want to find that out on a test day. Okay, that gave you 0.848. Now, that's not the angle, that's the sine of the angle, so we can't round it. We need to write out all the decimals we possibly can, or store them into memory, because we didn't want the sine of the angle, we wanted the angle itself. So we're going to have to unsine it. B is going to be we're going to have to do the inverse sine of that. So that probably means hitting the second button. Second sine brings up the inverse sine, and then on the calculator I'm using, I can use second answer to bring up that last answer, or you'd have to type it in. That's giving me 58.0519, and for an angle today, we're rounding them to one decimal place, that's 58.1 degrees. So now we know angle B. Now we have to find either side length C or angle C. Now we can't do this yet, and this is what we have to do to work out side length C. We can't do something when we don't know when there's two unknowns. So we can't do law of sines yet, but we can find the third angle in a triangle by subtracting. So this is angle C, is going to be 180 degrees minus angle A minus angle B. Yeah? So it's going to be 180 degrees minus 135 degrees minus 58.1 degrees. You put that in the calculator and then you scratch your head and go, oh, that's not okay. Because what comes out is negative 13.1. Oh, that's impossible. There is no solution to this triangle. So we've done all that work, and was all that work really necessary? No, I didn't need to do that. Let's just get that. Oh, don't want that one. Yeah, we don't want that one. Let's go back to what we were given in the first place. We should have been able to look at our first initial diagram and looked at it and said, you know what, a triangle can only ever have one obtuse angles because it can't have two angles that are bigger than 90 degrees. So if you have an obtuse angle, it has to be, there's no option. An obtuse angle must be the biggest angle. If it's the biggest angle, then the side opposite it must be the longest side. Oh, it's not the longest side. If we didn't have to do any work at all on this problem, if we just drawing the picture helps, and looked at it, then we could have been told right from the beginning there is no solution. If you have an obtuse angle in a triangle, the side that is opposite must be the longest side. If it's not, you have no solution. Okay? Look at what we were given here, by the way. What sort of problem were we given? We were given a side, and an angle. We've just been given a donkey of a problem, otherwise known as an ass. That wasn't even a cute ass. It had a obtuse. That was an obtuse ass of a problem. Okay, hope you're not offended by my language. So let's have a look at some more of these. We're going to be doing a lot of these today. Okay. Find all solutions for the given triangle, if possible. If no solution exists, write no solution. A little hint here. We have been given a little donkey. And in fact, we really have been given a little donkey. Let's draw this. We've been given one angle. So where am I going to put it? I'm just going to draw some random triangle here. And I'm going to put the angle I've been given on the lower left. Okay, that was angle A. So the side opposite it must go here, must also be A. And then I told you any other side you've been given, put that on the left. Don't put it down at the bottom, put it at the left. That's going to be because sometimes we're going to want to calculate the height of that triangle, and that's going to really help us. So that's the given information. Just like the last problem, we've been given an opposite pair. We've been given an angle and an opposite side. So we can set up the law of sines. And then we would have to find angle B because we know side length B. We can't do anything about C and C on this example because we don't know them. So we're going to say the sine of B divided by side length B, cross multiply again, cross multiply, anything that's down there will go up onto that side. Yeah. Good. Tap that in your calculator, see what you get. But write it out first. I do want to see this work. I want to know what you attempted to put in your calculator. That gives you in your calculator opens a parenthesis there. Make sure you close it before you divide. This gives you 1.237509061. That isn't angle B, that's the sine of angle B. So to remember to get rid of the word sine, what will cancel it out is its inverse. We're going to do the inverse sine of that. Tap it into your calculator and see what your calculator says to you. My calculator says to me, domain error. Depends what type of calculator you've got. Some calculators might just say undefined. Can anybody see what's happened here? Can anyone see what the problem is? Can anyone tell us why our calculator rejected this calculation? Said you can't do that. That's a domain error. Domain error is a huge clue. Anyone? The sine function, we got a value of sine to be 1.2375. What's the range of the sine function? This sine function, what's its range? Think about it. Here's a graph of a sine wave. Goes on and on and on forever. What's the highest point it ever reaches? 1. What's the lowest value it ever reaches? -1. The range of sine is from -1 to +1. We got 1.2375. We got a point up here. No angle in the world has got a sine of 1.23. And remember, the range of sine becomes the domain, otherwise known as your inputs, into the inverse sine function. The only numbers you can put in here are between -1 to +1. We tried to put in something that was too big. That's why it's undefined. Okay, so guess what we were given? We were given another ass of a problem. And look, I'm going to call this one very specifically, and this is, I know it's sort of messing around, but it's actually helpfully messing around. Look at this little ass. Is he a cute and little ass? Look what we were given. This is an acute angle, and this side here is little. The corresponding side is little compared to the other side we were given. When you've been given a cute little ass, you have not got a cute little problem. You're going to have a case here that you've either got no solution or the absolute nightmare where you have two full solutions to work. So it'd be useful. Sometimes it is possible for it to have one solution, but that would be a special, it would be a right triangle, and it's going to happen so rarely. And we would really struggle to write a question that came up exactly as a right angle. It's very rare for us to be able to do that. So it would be useful if you had a way, before you actually started doing the work, to actually work out there's no solution. And how you can do that is calculate the height of the triangle. And this is why we always say, put this one angle here, have this side here labeled, because then this height is opposite the angle 63, and the 25 is the hypotenuse of this little right triangle there. So your height would be the hypotenuse 25 times the sine of that angle. Work out what that is. Let's see what we get. You get 22.275. Let's just call that 22.3. That will do. If this height was 22.3 tall, if the triangle's 22.3 tall, and you were drawing a side that was only 18 long, can it reach the bottom corner here? It's shorter, that's 22, 18 would be about here. It's no way it can reach this vertex down here. This is too short. Oopsie. It's too short. It's shorter than the height of the triangle. It cannot reach the base. Because it's shorter. A is shorter than the height. There's no way it can reach the base of the triangle. And if we'd worked that out first, we wouldn't have had to do any of the subsequent work. So let's try another solution. Let's try another one. Oh, we've got a joke before we move on. Second joke of the day. I hope you remember, what do you call a reindeer with no eyes? No idea. What do you call a reindeer with no eyes and no legs? Okay, somebody asked me, do we have to use the shortcuts we've been showing us to see if there are no solutions, or can we just work them out and see if there are no solutions? Well, it takes longer to work them out than to use the shortcuts. I'm going to show you how short those shortcuts are. We might not have time today, but we definitely will at the beginning of tomorrow. And on a quiz, if you don't do the shortcuts, you're not going to finish. Okay? They really do help. Okay, this joke here. What do you call a reindeer with no eyes and no legs? Any idea? Think for a bit. Still no idea? Still no idea. I'm sorry, it's a terrible joke. Oh, well, never mind. Okay, moving on. Okay, right, let's look at this one. I haven't actually given the angle there. What you should always do, now what I'm going to talk about here is just the height of a triangle and the effect it has. Okay? As long as this side is longer than the height, let's call this little side x. If x is longer than the height, there is a solution. If x is shorter than the height, there is no solution. In this case, though, there's more than one solution. Can you see this side here, 8? I could get that same side, I wonder if I can do this, and swing it around so it's the same length. What am I doing? Oh, I've messed up the length there. And that's not what I meant to do. And it could join there. Can you see you can have two solutions? You could have, I'm just going to draw this triangle and move it out of place. That's got the same angle x, the same side length 10, the same x side length here of 8. I just swung it a different way. Just two solutions. In this solution, I don't know what this angle is, so we'll call it y. In this one, we get an acute y. And in this one, I'm going to have to call that y prime, a different name. This one is obtuse. When does that happen? When this side is shorter than that one, you're given a short corresponding side and an acute angle. If you've got a short, cute donkey of a problem, you have to work out the height to know how many solutions. If you don't work out the height, you're going to miss it when there's two solutions and you're going to lose 50% of the work. And you might also waste time doing work when there should have been no solution. If you've been given a short, cute donkey of a problem, always first work out the height. Okay, now the next problem we're going to do is going to be one of the ones where there's two solutions, like I kind of modeled here. These are long. Use a whole sheet of paper. Start a new sheet of paper and get this one beautifully written out. This one you want to keep as a model solution to look back on when you're doing problems. Now we've been very boring. We keep on calling the angle A. I'm sorry about that. But when you've been given, this is an angle, and it's, look, we've been given its corresponding side and another side. So we have been given a side angle problem, and this is acute, and its corresponding side, same letter, that is shorter than the other side we've been given. We've been given a short, cute donkey of a problem. And this one is going to turn out to be the nightmare situation where we actually have two solutions. So let's first of all draw it. Remember I said try and put the angle and the non-corresponding side to the left. So just draw a random triangle, fairly random triangle. The angle you've been given, put it on the left. Put all the A's and B's and C's, etc. on the triangle. Its corresponding side must go opposite it. We've been given another side, which we're going to write here, and that was side length B. So this is angle B. So we weren't told, but it must be triangle angle ABC. So side length C and angle C, we don't know. And we've looked at it and we've realized we have a short, acute, and look what we've got here, side angle. We've got a short, cute donkey of a problem. And I'm telling you right now, if you do not work out that height, you're in for trouble. Just work out the height. And this is why I want you to always set it up that way. And then the height is very simple. Your height equals this side here times the sine of this angle. It's always the same. You don't have to think about it very much if you do it that way. Okay. Let me just move that a little bit. I'm working on top of something here. So put that in your calculator, see what you get. We get 7.07. Okay. Now compare it to this corresponding side, the side that was short. 9 is greater than 7.07, so it is solvable, but there's not going to just be one solution, there's going to be two solutions. So later on down the page, don't do it yet, don't divide your page in half yet. There's some work that's the same for both solutions, but we are going to have two solutions for this because this side was shorter than that one, but it was still longer than the height. So we will get two solutions. So let's think about how we're going to solve this. We're going to start off with the law of sines because we have an angle and its opposite side. So we're going to do the sine of 40 divided by 9. Move some of this stuff out of the way. And we're going to set it equal to, we can't work out the c's, we're going to do the b's next. So we've got the sine of b divided by its opposite side, which is 11. Cross multiply. So move this, multiply this 11 onto the other side up there. Okay. That gives you sine of b equals 11 sine of 40. Plug that into your calculator. Just write down, actually, I'm not giving you time to put it in your calculator. Please just write down my values. I want this example completed in class, and it's going to be long. So sine of b equals 0.785629. Now you have to use the inverse sine function to work that out, and it's okay. You can put in 0.78. You're not going to get an error. When you put it in, you're going to get this answer here. B is 51.7789 degrees. We're going to round that to one decimal place and call it 51.8 degrees. Okay? Now that's going to go in our first solution. We've said there's two solutions. At this point, divide your paper in half and work side by side. If you work side by side, you can sort of match the work you're doing. These are going to be two totally different solutions, but what you do, you're going to be doing the same type of work. This one's going to be our acute solution, and this one, solution number 2, is going to be what I'm going to call our obtuse solution, and you'll see why for sure now, okay? In both of these, we were given those with the same starting information. We're given A equals 9, side length A equals 9, B equals 11, and angle A is 40 degrees. That given information doesn't change. It's the same in both triangles, but everything else about the triangles is going to be different. So I'm going to call this one my prime and that one my non-prime, okay? This first solution here, so on both triangles, I've still got to find angle B, angle C, and side length C. That's what the 3 pieces of information we have to find. So in solution number 1, I'm going to get that B I got over there, and so we worked out that angle B is 51.8 degrees. On this one, we're not going to get that. We're going to get a different angle, and let me explain to you what it is and why it happens. I'm going to call it B prime. At this point in our work up here, we use the inverse sine function. Now remember about the inverse sine function, it's got a restricted output. Inverse sine is only ever going to give you, do you remember from cos sine? It's only ever going to give you information from the right side of the circle. Okay, if I put a circle in there, a circle of radius 1, so this top value is 1 down here, and the bottom value is -1, those were points. And the angles, to come down to here, we used to call them this -pi/2. That's in radians, we're in degrees now. That's -90 degrees, this is +90 degrees. Inverse sine can only ever give you an acute angle. So the sine we were putting in there was 0.7856. This is 1. This is about 0.7856. This was our angle B, this angle here. However, look at that. Your calculator can only give you one answer. It can't give you anything from that shaded out zone. But we know that this angle also exists. This is our alternate solution, our B prime. So how do I work out the size of B prime? Using symmetry, if this part here is 51.8, this part here is 51.8 as well. So my angle B prime is going to be supplementary. It's going to be 180 degrees, subtract my other solution. So that gives me, put that in your calculator, and you get 121.2, is it? Oh, I'm going to have to do the work. My brain stopped working. (128.2 degrees). So that is our alternate version of our angle B. So now in both triangles, we know the given information, we found angle B, we still have to find angle C and side length C. And that'll be different in both solutions. This triangle looks a bit like this. This triangle looks like this. It's that other solution, and that side's gone over there. Ugh, that's ugly. I'm just going to take it out for more work. Right. So how do I find? How do I find the third angle in a triangle? All you do, my third angle is going to be angle C. It's going to be 180 degrees minus the other two. So it's going to be exactly the same work here, but it's going to be a different angle C. So I'm going to call it my alternate angle C. It's still going to come from 180 degrees minus angle A, because that's the same for both of them. On this one, I have to take away B prime. So on this one, my angle C is 180 degrees minus 40 degrees minus angle B. And on this one, 180 degrees minus 40 degrees minus B prime, this one here. So work out what that is for both of your triangles. This one, it's 88.2 degrees. That was C. And on this one, it is 11.8 degrees. And I'm calling this C prime. It's my alternate solution. So I still haven't finished. What do I still need to find on both of them? I found the third angle. Now I have to find the third side length. I'm going to do that using the given information, law of sine. So I'm going to do the sine of angle A divided by side length A, which was 9. And I'm going to do the sine of angle C divided by side length C. And how big is angle C? On this one, it's 88.2. And on this one, okay, so you finish off the problem like that. Don't leave for a second. I know you want to leave for a second, but there's something I want you to see that's there so you'll know what I'm talking about when you're trying to do your homework. Take me 30 seconds. You'd finish off that problem. When you're using the inverse sine function, remember it's got restrictions and it's only ever going to give you an acute solution. But if that short side was longer than the height. It's all about the height of the triangle. There could have been an obtuse solution that existed too that your calculator is incapable of returning for you. So when you've been given the law of sines, when you've been given a side-side angle problem, there could be no triangle, one triangle, or two. If you always draw it this way I just told you, set it up where one angle is here and you've got your side-side angle, then you can use this flow chart. If the given angle is obtuse, the side opposite it must be the longest side. If it's shorter than the other side, you have no solution. If the angle you've been given is acute and this side is short, if A is shorter than B, you've got a real headache. Check the height. If this side is longer than the height, you're going to have two solutions. If this side equals the height, you've got a perfect right triangle with one solution. If this side is shorter than the height, no solution is possible. If this side is longer than B, if it wasn't a short, cute ass, if it was a long, cute donkey, it's nice and easy. There's just one solution. So you have homework. You really need to do it tonight. This flow chart is available for you to print just online in the notes. I'm sorry I held you back for a minute. Off you go, guys.